Welcome to Clark Classroom. Don't forget to subscribe. In my previous video on introduction of vectors, I indicated that there were two systems in which we perform operations on vectors: the free floating system and the coordinate system, or position vectors. In this video, I look at some examples on how we solve problems in both systems. Let us look at this example. The angle between two forces of magnitude 10 newtons and 6 newtons is 45 degrees. Find the resultant force R and the angle between R and the 10 Newton force. Correct to 2 decimal places. You will need to have knowledge of the law of cosines and the law of sines. Here I illustrate the problem. Observe that in the previous video, the angle between the vectors is obtained when you have the vectors with a common origin. And so the angle between the 10 Newton and the 6 Newton force is 45 degrees right there. In the free floating system, also note that we can translate the vector, the 6 Newton vector, to this position so that we have them aligned head to tail. When they're aligned head to tail, then the vector from the beginning to the end is our resultant vector. Also note that if this angle is 45 degrees, since these two vectors have the same direction, it means they are parallel. And these two angles are what we call co-interior angles. They are supplementary. So if this is 45 degrees, then this one will be 135 degrees. And now we refer to this as the triangle of vectors. And to solve for R, we simply use the law of cosines to determine the length of the vector R, which would be the representation of its magnitude. So here we have R squared will be equal to 10 squared plus 6 squared minus 2 times 10 times 6 times the cosine of 135 degrees. This is equal to 100 plus 36, subtract 120 times the cosine of the angle 135, which gives us negative 0.7071 to 4 decimal places there. Notice that I have given this result to 3 decimal places. If you're trying to get 2 decimal places in your answer, then you will need to be working with at least 3 decimal places in the problem before you get to the final answer. And so R here is now, since this is R squared, then R is now the square root of 220.853, which is equal to 14.86 newtons to 2 decimal places. And now to determine the angle theta, which is the angle between the 10 Newton force and the resultant R, we use the law of sines. So the law of sines tells me that 6 over the sine of theta will be equal to 14.861 over the sine of 135 degrees. Note also that I kept the 3rd decimal place from this answer to work through the problem with 3 decimal places so that I can get a better accuracy for 2 decimal places in my answer. So the arithmetic here tells me that sine theta is equal to 6 times the sine of 135 degrees divided by 14.861, which comes out to be 0.2855. And so theta will be equal to the inverse sine of this number, which comes out to be 16.59. And this square indicates that we are at the end of that problem. And now we will solve the same problem using the coordinate system or the position vector system. I want to direct your attention to this diagram here on the left. The vector r may be expressed as pairs of two other vectors. You see here the green pair and the red pair. Now these are only two of the infinite number of pairs of vectors that you could get to go from the beginning and to the end of the vector r. We are interested though in these two, one being the horizontal and one being the vertical. We refer to these as the components of the vector r, and we refer to the process as resolving. So we can resolve r into the green pair, or we can resolve r into the red pair. As I indicated, the red pair is what we are most interested in because it sets up a right triangle that is very easy to work with. So if we look at these two components and apply the basic trigonometry values, we'll see that the vertical component would be equal to r times the sine of theta, and the horizontal component would be equal to r times the cosine of the angle theta. So let's look over here at this diagram. Here we have the vectors a plus b to give us the resultant r. If we resolve a into its two components, the x component and the y component, and we do the same thing for b, resolve it into its x component and its y component, then we see that the two x values for a and for b would make up the total x value for the resultant r. Similarly, the y value that we have resolved a into plus the y value that we have resolved b into, the sum total of these two pieces will be equal to the y value of the resultant vector r. And so we can use those two components to determine the value of r. Once we have the horizontal component, which is the x value, and the vertical component, which is the y value, we can now use the Pythagorean theorem to determine the magnitude of r. So, resolving these vectors, let's look over here. And we see that we have here the 10 Newton force and the 6 Newton force. And the angle between them is 45 degrees. Again, we are interested in the angle theta, which is between the 10 Newton force and the resultant r. So, resolving the 10 Newton force and the 6 Newton forces into their x components and y components, we have the resultant vector, the x value for the resultant vector to be equal to 10 times the cosine of 45 degrees plus 6. Notice that we do not have to resolve 6 into its x component since it is already in the direction of x. So it's 6 units long in the direction of x. Similarly, the y component of the 10 Newton vector would be equal to 10 sine 45. And since the 6 Newton force is in the direction of the x-axis, then the y component would be 0. So the y component of the resultant vector will be 10 times the sine of 45 degrees plus 0 to give us 7.071. And now that we have the x value being 7, being 13.071, value being 7.071. We can now use the x and y values to determine the value of r. So r will be equal to the square root of the x component square plus the y component square to give us 13.071 square plus 7.071 square. And the square root of that comes out to be 14.86 Newton. That's it. And now to find the angle alpha, we'll use the tangent of alpha would be equal to the rise to the y component over the run, which is the 13.071. So alpha would be equal to inverse tan of 7.071 over 13.071. And so alpha comes out to be 28.412, but we are interested in finding theta. And so we subtract from 45 degrees alpha to get the value of theta. So 45 subtract 28.412 gives us the two decimal places 16.59. And here we come to the end of the problem, obtaining the same two answers that we got in the free floating system of vectors. If you find this video useful, please subscribe to this channel, and I welcome your comments and or suggestions.